Alright, the last integration technique of this course is called integration by parts. This is for BC kids only. So this is for when we're going to be integrating a function times a function. And it's really for when it's a non-polynomial function. So for example, by a polynomial function, I mean if you have something like x plus 3 times 4x minus 1 to the 6th, that could be turned into a polynomial if you were to combine things. And so that was ideal for what we call the U substitution. So if you go back to the U substitution video and the examples that we looked at there in that video, we saw that they resembled a polynomial times a polynomial. Okay, so that's when you're going to use the technique of U substitution before. So please make note of that. All right, so this is when we have a function times a function, and it's not a polynomial. So you see the x times the cosine of x. So here is the formula that you need to memorize for what we call integration by parts. Okay, so let's jot it down. All right, so there we have it. We have the integral of u dv, so there's a mismatch there of letters. That is going to equal the product of u and v minus the integral of v du. So what in the world does this mean? So let's apply it to this example. So we have two parts to this. All right, we have this x as one part, and then we have this cosine of x dx as our second part. And yes, we want to include that dx as our second part. So what we do is we assign usually the first part u, and the second part is dv. So that resembles what we see up above here. We are looking to integrate u times dv. Okay, so again, we're going to let u be x, and then the dv is going to be the cosine of x dx. All right, and so what we need to do next is we're just going to copy this down. So u is x, and then dv is cosine of x dx. Now in our formula, notice we have a u, we have a v, we have another v here, and we have a du. Okay, so we see a du, so that means I need to find out what du is. Well, if u is equal to x, du would be equal to 1 times dx, because the derivative of x is just 1. So we say that du is equal to dx. So to go from u to du, we got to do a derivative. And then we're going to need to figure out what v is, because again, we see v's in our formula. So a dv represents a derivative. So if we're going to go from the dv to the v, we're going to have to find the antiderivative. So we're going to have to integrate cosine. Well, when we integrate cosine, we're going to get sine. Okay? So we're not going to worry about the plus c, we're just going to write it as sine of x. Okay? So to go from dv to v, you integrate. So now let's fill in these pieces into our formula. Okay? So we're integrating x times the cosine of x dx. This is equal to, we said, u times v up here in our formula. So my u is x, my v is sine of x. Okay? Then we have minus an integral. So notice the formula has another integral in it. Okay? So what is it we're integrating? Well, we have v du. Well, just look from our givens here for what we found. All right, the v is the sine of x, right? We found that. And then we also found the du. We said that du is equal to dx. So I'm just substituting in there. Okay? Well, from here, I'm going to just drop down this x sine of x and the minus. And now I'm going to integrate sine. And notice how we now have a match in our variables, right? Up above here, we did not have a match, okay, in our formula, all right, but we do have a match once we do the substitution, and that'll always be the case. So when we integrate sine, we know we're going to get negative cosine of x, and so when we write out our final answer, x sine of x plus the cosine of x, and then plus c would be our final answer. Now I would encourage you to check this by doing your product rule. Okay, you would have to do your product rule on this x times the sine of x. All right, and then the derivative of this cosine would be negative sine. All right, combine your like terms, and you would see that you're going to end up with what we started with back up here. Okay, so off to the side, I would encourage you to do that. All right, so sometimes our integration by parts is going to have to be done 2 times in a problem. So that's going to be evident in this example. So most of the time you'll just have to do it once, but sometimes you'll have to do it more than once in order to get to your final answer. So let's take a look. So we have this x squared times this e to the x, and then off to the side here, let's just recall what our formula is. Okay, u dv, if we're integrating that, it's going to be u times v minus the integral of v du. Okay, we've got to commit that to memory. Okay, this is our basic formula. So usually we let this first term be u, and we let this other part be our dv. So you can see how that would now match our formula here. We would just have the integral of u dv. So from there, get in the habit of transferring those down below. Okay, we have the u on one side, the dv on the other. Okay, with the u, we're always going to have to find a du because we see there's a du in our formula. So this is going to be 2x, and then we tack on a dx because it's with respect to x. Okay, and we see there's a v in the formula, so we need to find our v. So again, if we have a dv, we're going to have to integrate to get it back down to v. So when we integrate e to the x, well, that's e for easy. We just have e to the x, and again, don't worry about a plus c at this point. So now it's just a matter of plugging into our formula, guys. So we have this u times v, so the u is x squared times the v, e to the x, minus an integral of v, which is e to the x again, and then our du is 2x dx. Okay, and so if we look at what's left here for our integral, notice how we don't know what this is because there's an additional x in there, right? And so we're going to need to do our integration by parts again. Okay, we don't know what this is equal to, so we need to do it all over again. And it's the same idea, but now you're just going to have a different u and you're going to have a different dv. All right, all these parts are going to be a little different. So let's start by rewriting this. So we have x squared e to the x. And let's flip-flop what we have here. Now we see this 2. We know we can pull that 2 out in front. So I'm going to take that 2 up. I'm going to pull it out in front of the integral just to clean this up a little bit. And I'm going to put the x first before the e to the x. Okay? So again, if you have the opportunity, if you have a constant inside, like the 2 that we see here, pull it out in front so you have less to deal with. Okay? So we have our x squared e to the x minus 2, and then pretend that this is the new mini problem within the big problem. Okay? So we're going to let this x be our u, and this e to the x dx be our dv. So u is equal to x, dv is equal to e to the x dx. So the derivative of u is du, the derivative of x would be 1, and then dx. And then working backwards here, we have dv, and we need v, we need to integrate, so we have e to the x. So now let's go back, and we're going to substitute in, and I'm going to put a parenthesis here because we're going to have to distribute this negative 2 to our parts of the formula. So the formula says u times v, so we're going to have an x times an e to the x minus an integral of v, which is e to the x, and then du, which is dx. Okay, so let's copy down what we have. We have x squared e to the x from before. I can begin to distribute my 2. So I have a minus 2x e to the x. I'm going to have a negative 2 times this negative in front, which is going to make it into a positive 2. And then when I go ahead and integrate e to the x, I know I'm going to get e to the x. And this is where I'll finally tack on my plus c. So this is my final answer. This is pretty much as tough as it gets for integration by parts. Again, it's because you have to do it 2 times within the problem. All right, last example. So some notes here. The u, right, whatever we consider u, okay, is not guaranteed to always be the first part. In the examples we've seen so far, we've let u be that first part of the product, and it's worked out fine because the second part, the part we call dv, we have been able to easily integrate. So you have to keep in mind, whatever you call u, you're going to have to take its derivative, and whatever you call dv, you're going to have to take its antiderivative. So if we look at these two parts here, x cubed versus ln of x, in this situation, it's going to be a bear to try to integrate ln of x. Now, yes, we did look at the formula for integrating ln of x, but it's certainly possible that you're going to forget it. It is a formula that is not very easy to remember. So it's going to be a lot easier to take the derivative of ln of x, which we know is 1 over x, than it would be to try to remember its antiderivative. Okay? So the x to the third, it doesn't matter either way. It's pretty simple whether we take the derivative or the antiderivative. So what I'm saying is we want to call this part u. So we want to let u be ln of x and let our dv, that part, be x cubed dx. Okay? Again, the reason is it's going to be much easier to find our derivative here. So the derivative of ln of x is 1 over x, and we tack on a dx as a reminder that it's in terms of x. And when we integrate this, again, to go from dv to v, we have to integrate. That's just x to the 4th over 4. So if you had called dv ln of x, again, if you don't have that formula memorized, it's going to be impossible. So even if you do have it memorized, it's still a lot messier to do it that way. So from here, let's plug into our formula. So we would have our u times our v. So I'm going to write this as 1/4 x to the 4th ln of x. So that's my u times my v, minus the integral of v du. So the v is another 1/4 x to the 4th, and the du is 1 over x dx. So again, this is the u times v minus the integral of v du. That's what we just did there. Okay. So let's clean this up a little bit before we go ahead and integrate. So if we have 1 over 4 x to the 4th times 1 over x, this 1 over 4, we can put that out in front of the integral, and this x to the 4th is going to be divided by that x, so that's really going to be the integral of x cubed. Okay, so we have 1 over 4 x to the 4th ln of x, and then from there minus 1 over 4, and then we're going to now integrate x cubed, so that's x to the 4th over 4, and from there we have 1 over 4 x to the 4th ln of x minus, turn that into 1 over 16 x to the 4th, and then plus c. Okay? Thank you, and have a nice day.